This is problem 1033A, King Escape. So let's summarize the question. Alice and Bob are playing chess on a chessboard with dimensions n times n. Alice has only a queen left, located at a set of coordinates, while Bob has only the king left, standing at another set of coordinates. All Bob needs to do to win is to march his king to a target square in order to claim the victory for himself. Alice's queen does not move. But Bob must move his king from its current location to the target location without ever getting in check. A king can move to any of the 8 adjacent squares. A king is in check if it is on the same rank, file, or diagonal as the enemy queen. And we must find out whether Bob can win or not. So let's move on to our input. Our first line will contain the dimensions of the chessboard. Our second line will contain the coordinates of Alice's queen. The third, the coordinates of Bob's king. The fourth line will contain the coordinates of the target square or the location that Bob wants to get to. And it's guaranteed that Bob's king is not currently in check, and the target location is not in check either. The king is not located on the same squares as the queen, and the target does coincide neither with the queen's position or with the king's position. And we must print yes if Bob can get to the target square without ever getting in check, otherwise we print no. So now let's take a look at our first test case. Here, the queen is on d4 and the king is on a3. We immediately see that the queen has boxed the king in and controls the diagonal right down the middle. And say if the target square is c2, the king cannot directly reach it as he would be entering the diagonal that is controlled by the queen. But the king can get around it by moving to b3 and then to c2. Now we move on to our second test case. Here the target square is a6, the queen is still on d4, and the king is now at b3. The queen has once again boxed her king in to his quadrant, but the queen also divides the king from the target square on a6. So the king cannot reach the target square and therefore loses in this test case. Alright, now let's get into our third and final test case. In this test case, our king is on a2, the enemy queen is on c5, and our target square is f1. The king is, once again, boxed in, and the queen is separating him from the target square. So now we're starting to see a trend. While we could try to solve this problem by tracing every single path that the king can take to his target square, and if there are none, then we declare the king is lost, I have a better idea. Test cases and put it into code. To visualize our algorithm, we can go back to our second test case. Here, we can see that the queen divides the board into 4 different quadrants: the top left, the top right, the bottom right, and the bottom left. We can see that the king is in the bottom left, and the target square is in the top left. Since the queen is separating them, we can see that the king cannot reach the target square and therefore cannot win. We also notice a pattern emerges. Here, we see that if the target square and the king are not in the same quadrant, the king cannot win. If they are in the same quadrant, the king can win. For example, in this test case, as I've said, the king cannot win as the queen is separating him and the target square. But if we put the target square here, for instance, the king can still reach it, avoiding the diagonal that the queen controls. Now let's put this into code. Firstly, I've created arrays, and the first element will be the x value and the second will be the y for the queen, the king, and the target square. So firstly, we want to see if the king is on the right side of the board or the left compared to the queen. If the king's x-coordinate is larger than the queen's, then we can see that the king is indeed on the right side of the board. Otherwise, it's on the left. Here we can see that the king, relative to the queen, is not on the right side of the board. It's on the left, as the king's x value is less than that of the queen's. Next, we check if the king's y value is greater than the queen's. If it is, the king is above the queen. Otherwise, the king is below the queen. Here we see that the king's value is less than that of the queen. So the king is below the queen. And we repeat the process for the target. Lastly, we check if the king and the target are in the same quadrant. First, we check if the king and the target are on the same side of the board horizontally. Then, if that's true, then we check if the king and the quadrant and the target are on the same side of the board vertically. So, in this top half and the bottom half. If they are, then the king can indeed reach the target, as the target is in the same quadrant. Otherwise, the king cannot.